Let's do the curve sketching for this equation. The equation is given that f of x is equal to x over x plus 4. So in order to do the curve sketching, we have to know these 8 things. First of all, we have to know the domain, intercepts, symmetry, asymptotes, intervals of increase and decrease, local max minimum, concavity, and points of inflection, and finally we sketch the graph. So first of all, I find the domain. So in this case, domain. So only thing we have to consider when we consider about the domain, the only thing we have to care about is the denominator shouldn't be equal to 0, because if the denominator is equal to 0, then that will become undefined. Therefore, we have to be careful about that situation. So in this case, let's see what is the condition that's going to give the denominator equal to 0. So we have denominator x plus 4. I write this one down right here. It's going to be x plus 4 is equal to 0. If I set this one equal to 0, x is going to be equal to minus 4. Therefore, we know that the domain is not going to be exist in minus 4, because if the minus 4 exists, then that point is going to be undefined. Therefore, we shouldn't include that. So therefore, the domain is going to be equal to x can be any real number except negative 4. So that's my domain for this equation. Now let's move to the second part. Second part, we have to find the intercepts. So there are two intercepts, x-intercept, y-intercept. So first, to find the y-intercept, I have to set the x is equal to 0. So in this case, if I set the x is equal to 0, what's going to happen? 0 over 0 plus 4 is going to be 0 over 4. That's going to be 0, right? Therefore, y-intercept is going to be y is equal to 0. Y is equal to 0. Then x-intercept is the same thing, like you have to set the y is equal to 0 and find the x value. So when you set the y is equal to 0, this one multiply the other side, and then that one becomes 0, therefore x is equal to 0. So that's my x-intercept. Therefore, we know x-intercept is 0, y-intercept is 0, that's all about it. And then we have to check symmetry. So there are two symmetry possible, odd symmetry and even symmetry. So let's check that one. So to find the symmetry, what we have to do is we have to set the f of x into f of negative x and find what is giving. So if I set f of negative x, I will get negative x on top, and in the bottom it's going to be negative x plus 4. But is it equal to, like, first of all, f of negative x, is it equal to f of x? If you look at this, it's no. So this is not an even symmetry. If you want to check odd symmetry, I have to check whether it is f of negative x is equal to minus f of x. Is it minus f of x? No, because if it's minus f of x, then it's going to be minus x, minus 4. But it's not minus f of x. Therefore, this is not odd symmetry or even symmetry. Then let's move to the next part. We have to check the asymptotes. So vertical, first of all, let's begin with the vertical asymptote. To find the vertical asymptote, I have to set the denominator into 0. So here we have x plus 4 in the denominator. So if I set that one into 0, x plus 4 is equal to 0. Therefore, x equal minus 4. This is my vertical asymptote. So to find the horizontal asymptote, what I have to do is I have to find when limit x approaches infinity, what's going to be the y value. So in this case, let's do this one. So if I put that one, when x is, limit x approaches infinity, what's going to be the value. So before I do that, what I have to do is I have to divide everything by the highest power. In this case, we have only the x, so we divide everything by x. So x divided by x over x divided by x plus 4 divided by x. So let's see what it's going to give. In this case, it's going to be 1 right here over 1 plus 4 over x is going to be 4 over x. Now this is still limit x approaches infinity, and if I apply this infinity right now, what's gonna give us? Let's see. So 1 over 1 plus 4 over infinity is going to be 0. Therefore, 1 over 1 is going to be 1. So this is my horizontal asymptote. Horizontal asymptote is y is equal to 1. So these are the horizontal asymptote and vertical asymptote. And the next thing we have to find is intervals of increase and decrease. To find that, I have to get the first derivative of this equation. So let's see how we can do that. So first of all, first derivative, this is dividing each other, so I have to use the quotient rule. So according to the quotient rule, what's telling is we have to find the derivative of numerator first, multiply by the denominator, x plus 4 minus then derivative of the denominator multiply by the numerator divided by the denominator square. It's going to be x plus 4 square. Then if I calculate the value, x derivative is going to be just 1 and x plus 4 on top, and in the minus, so this is equal to f of x derivative, and this is going to be x plus 4 derivative, so 4 derivative is 0, x derivative is just going to be 1, so it's going to be 1 times x, and in the bottom, if I square this one, I will get x square plus 8xh plus 4 square. Let's see whether it is necessary to do that. Let's see. Okay, so if I simplify this one furthermore, I will get f x plus 4 square right here, then f x derivative comes out to be 4 over x plus 4 whole square. So this is my first derivative. Now from this information, to check whether it is increasing or decreasing, I have to get the critical numbers. To find the critical numbers, first of all, there are two possibilities to get the critical numbers. First thing is I had to set the derivative into 0, like f prime x into 0, and find the values, and then I have to find the situation where this equation is undefined. So first of all, if you set this one into 0, from this one you can say there's no solution for this one, because if you see numerator is just 4, there's no x or whatever it is. So since there's no x, so nothing in this denominator, if it goes to the other side, it multiply by 0, it will become 0. Therefore 4 is equal to 0. That doesn't make any sense, right? Therefore there's no solution for the setting this one into 0, but there's a possibility that undefined situation. So in this case, if I put then x is equal to -4, that's going to be, this equation is going to be undefined because it's going to be 0. Therefore that's going to be undefined. So that's the only critical number we have. So x is equal to -4 is the only critical number. Then we have to find the interval increase and decreases. So since we have only critical number, we have to find the values below and above this value, positive or negative. So if I apply, let's see. So in this case, I have to pick up a number that's below -4. If I pick up a number below -4 and put this here, negative, let's say -3. -3 square is going to be a positive number. Positive number divided by positive number is going to be positive, so it's going to be increasing. And then if I pick up a number above, it's still going to be positive, because whatever value, if you square negative or positive number, if you square it, it's going to be positive, and if you divide any positive number by positive number, it's going to be positive. Therefore both of them are increasing, and we know this is going to be this. We found that x minus 4 doesn't exist, so it's not going to touch here. But let's see what's happened after this. And then we have to find local minimum and local maximum. Since we have increasing and this point doesn't exist, there's no local maximum or local minimum, so that question we don't even have to go for that one. Then next one is concavity and point of inflection. We have to take the second derivative. So we found the first derivative right here. It's f prime x is equal to 4 over x plus 4 square, and if I find the derivative of this one, it's basically the what is that, quotient rule, because it's dividing each other, so I have to do the quotient rule right here. And if I do the quotient rule and find the final answer, it comes out to be -8 over x plus 4 cube. And in this case, is same thing as the first derivative, because if you see, we only have -88 on the top. If I set this one equal to 0, there's -8 is equal to 0. That's not going to give us solution, so that critical point does not exist. But in this case, there's a possibility that this equation can be undefined. That's when x is equal to -4, because if you plug -4 the x value, this will become, denominator becomes 0. That will give us undefined. So that's going to be the only critical point in this situation. So we can say x is equal to -4 is the critical point. Therefore we can find the values below and above this -4, positive or negative, and determine the concavity, right? So let's begin in the other side. So I take the -4, and if I plug the -3 in this equation, what's going to happen? Let's see. So -3 plus 4 is going to be positive. Positive power cube is going to be a positive value, but if you divide positive negative value by a positive value, that's going to give you So I'm taking wait a minute, so -4 I'm taking, so -3 means I'm taking above -4. So -3 plus 4 is going to be 1 cube, so it's positive divided by negative is going to be a negative value. So it's minus 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 minus, it means concave down. Then if I take a value below -4 is, let's say, -5. So -5 means -5 minus plus 4 is going to be -1. -1 cube is going to be a -1, because if you cube any negative value, it's going to be a negative value. Therefore, negative divided by negative, that's going to be a positive. That's going to be a positive value. So if here it's going to be a positive, 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 that's going to be concave up. So now we are ready to go. Those are the only information we have, and we don't have any inflection point because we know that x minus 4 does not exist from the first domain. We set the domain that we found out that x minus 4 does not exist. Therefore, this is not going to touch right here, so we don't have any inflection. So that's all about it. Let's draw the graph right now. So if I start the graph, okay, this is my x, like x-axis, y-axis, and we have to first let's put the horizontal asymptote and vertical asymptote. So horizontal asymptote is when y is equal to 1. So this is my horizontal asymptote right here. Let's say this is 1, and we have vertical asymptotes in the -4. So vertical asymptote is somewhere here. So this is -4, and then we have to consider everything. So first of all, we know the domain is going to be exact -4, so this graph is not going to touch this point. And then we have intercept y is equal to 0, x is equal to 0. Therefore, this is going to be going through this one. This point is going to be, this is the only point the graph is going to touch. And then we have, this is not symmetry, and also we have a horizontal asymptote, vertical asymptote. Then we have found out the interval of increasing and decreasing. So in this case, both of them are increasing. So let's see, below -4 it's increasing. Also below -4 it's concaving up. So increasing and concaving up. So we are going to get a shape something like this, and we have to make sure which value. So if I pick up a value below -4, let's see, if I put the value below negative, for example, -5. If I put the -5 in the first equation, -5 plus 4 is going to be -1. And if I put the -5 on the top, -5 divided by -1 is going to be 5. So we know that's y value is above this point. So this is increasing and it's going all the way up right here. So this is one of my graph. And this is going to be one of the part. And let's see other after -4 what's going to happen. So it's increasing, and here it's concaving down. Increasing and concaving down mean it's half of this parabola, like it's going to be something like this, increasing and concaving down, right? So this is the shape it's going to be look like. And also we know that it's going to be passing through this origin 0 0, because that's y-intercept and the x-intercept. Therefore we can draw the graph right now. So it's going to be passing through the origin and going all the way. It's never touched the intercepts, and it approaches the intercept. So that's how the graph is going to be look like. And this is how we do this curve sketching. And I hope you guys like this video. See you next time.